Morning. How is everybody doing? Fine, more or less awake. Okay. Yeah, it's still early. Let's see where we can take this. So let's talk a bit about trade-offs in security, which are always an interesting topic. I have, like we already heard, I work for Elastic, the company behind Elasticsearch and the Elastic Stack, and you might have seen something like this. This is approximately what we do, but I will mostly focus on Elasticsearch, which is the oldest product, and also where probably security matters the most, because that is where your data lives. And so one thing I once saw and found very interesting is this one, which is of course a joke, because yeah, just not having SQL is not making you very secure from any injections. You can still have other kinds of injections. But the more general question then is, did NoSQL improve security overall? Does anybody have an opinion on that? Or does anybody have any guesses? So I would generally tend on saying kind of no, because it's always like you have a new system and it starts and it evolves, and then security is probably not the main concern yet. So kind of the thesis that I have here is that when you have an initial product, come on in everybody. So when you have an initial product, like you had the NoSQL data stores, then what you really want is you want to have the ease of use so that everybody starts using you. So you will make some trade-offs that probably are not the most secure ones, but you just want to have the growth and be very easy to use. I think that was one of the main reasons why the NoSQL explosion like 10 years ago or so happened, that it was just much easier to get started and solve some problems. But it definitely came at the trade-off of security. So let's take a look at some of the examples of things that have been kind of like weird. So does anybody know what Elasticsearch was doing initially in terms of binding to interfaces and what it is doing now? Yes, exactly. So it used to bind to everything because that was the easiest way to get started. You didn't have to configure anything. It would just listen on all interfaces. We changed that in version 2, which was a long time ago already, because, well, a lot of people started running that on public instances and it wasn't listening to everything and there was no security by default, which was not a great way to get started, or it was a great way to get started, but it was not a great way for security. And we changed that over time. But that binding is something you need to change now by hand. But initially it wasn't there because it was much easier to get started like that. Does anybody know how clustering worked initially? That was another interesting one. So basically what clustering was doing initially was it would just scan the local subnet, and any other instance with the same server name that it found, it would automatically form a cluster. Which was again great for demos because you would just you would have 3 laptops in the room and then you would start them up with the default settings and they will automatically form a cluster. Which was great for demos and everything, but probably not so great for security. And we even had people report that they would VPN to their production system and had Elasticsearch running locally. And then it would form one big cluster and then they thought they were running something against localhost. And then they would drop the data in production. So again, for security, it's probably not the best thing that you have this automatic clustering. We got rid of that as well over time, but there might be cases where people did some weird stuff there. Then over time, we added something we call the production versus development mode, which generally the assumption is as soon as you bind to a non-local host port, so you could form a cluster, we assume that you're in production mode. And production mode will basically add some additional checks and constraints, whereas development mode will just give you some warnings and tell you, well, maybe something is happening there. So something that we do here, so this is the actual Java code in Elasticsearch, basically it checks, do you bind to any interface that is a loopback interface, or we have a single node mode, and single node mode is just for Docker. Why do I need that for Docker? Yeah, because otherwise I need to get out of the stupid container, or not stupid container, but I need to get out of the container. And then it would always look like I'm in production mode in Docker. But most people just want to try something out in Docker, so we kind of like built in a little loophole. What that thing cannot do is it cannot form an actual cluster. So this thing can be binding to a non-local host interface, but it cannot form a cluster with other instances, because our assumption is always for highly available systems, you need more than one instance. So as soon as you form a cluster, then you will be in production mode. But in general, we assume as soon as you could form a cluster, you bind to non-local host, then it would actually be production mode. And production mode has a lot of checks. Most of them are just for running it in a performant and secure way, but some of these checks will actually run into security. So for example, does anybody know what will happen if I try to run Elasticsearch as root? Nowadays, at least. Is that possible? Or is it a good idea? No. Okay, we all agree on the no here. Can you do it if you really want to? No, you cannot. So what we basically have is, it's definitely running as root is the method call, which I find great. On Windows, we don't know and we don't care. Because there's no easy way to find out, I think. But on any Unix-based operating system, there is the Java native access. And with that, you can basically check for some permissions. And we use that to figure that out. And what we then do is, when the process starts up in the bootstrap checks as well, is it throws a runtime exception and it will just exit. And it's over. Like if you try to run Elasticsearch as root, it will exit the process. And I guess everybody here says, well, that is a good idea. Nobody would disagree with that. And this is the right thing to do, right? Unfortunately, it's not always that easy, because then we had this one here. This is always good fun for security. And then we started, like, I always say, these are like the cockroaches, like things that you get rid of for some time, but they keep reappearing, like the cockroaches in the kitchen. Because then suddenly, in our Elasticsearch Docker repository, people say, like, this should be running as root. Like, why do you make it complicated? We don't care. And then you suddenly have these problems reappear where people want to do this. And then you have to argue why you don't want to run or allow to run the process to run as root. By the way, the only way to make Elasticsearch run as root would be to fork the code and comment out that runtime exception. There is no other way to force that in any way or anything. Yeah, I also call this kind of Docker often has this YOLO approach, like we'll do something just to get it running quickly. And that is what you see every now and then. Anyways, Seccomp. Does anybody know or is using Seccomp? Basically, you can filter which system calls are allowed from your process. So if you know that your process never needs to fork out another process, you can just, on Linux, disallow that. And this is something that we set, for example, in Elasticsearch. This might be very tiny, but you can see, for example, here this is the call for fork, and this is the call for execute. We just block those calls. So even if you take over the Elasticsearch process, you could never run these system calls because we know we never use them, so we just forbid them. You could even disallow network access for a process, which doesn't make much sense for Elasticsearch, but if you have a process where you know it will never need to reach out over the network, you could disallow that. And that's Seccomp, and how to actually do that. And we just call it the system call filter. Basically, we set up the profiles, what should be allowed in the beginning and what not. Scripting. Scripting is always good fun, right? And everybody wants scripting. So what we did was initially we added general purpose scripting. Like since Java is Elasticsearch is a Java process, we added Groovy because scripting and in the JVM and it was all running. Can anybody guess what happened? Yeah, people found ways to break out of the sandbox and lots of bad stuff happened. I think more than half of the security issues we had in the first couple of years for Elasticsearch were because of scripting, and somebody found a clever way to break out of the sandbox. Because we thought, well, you can only call this thing, and they found another way to call other stuff and break out of that. And it was kind of like whack-a-mole. And it's just not a good idea because the scripting language was not made for the purpose we tried to use it. For example, a friend of mine, he had an Elasticsearch instance running somewhere, and then it started sending so much spam that he couldn't even SSH into it anymore, I think, because somebody had broken through the scripting. So what we then did is we invented our own scripting language, which I'm not sure if that is the perfect solution that you always want to have, but that is what we did. And the general goal was security and performance. The nice thing is, by writing your own scripting language, you can basically define, like, this is the thing, these are the things that are possible, and this other stuff is just not possible. Like, there is no way to call another class because we just don't have the concept for that, which was one of the ways how to break out of the security sandbox. Performance was also another way, and then we got rid of all the other scripting approaches, which people didn't like because they had to rewrite the scripts. But for long-term security, this hopefully was the better approach. One thing Elasticsearch didn't do for a long time was that you didn't have to specify the content type. So, for example, with this one here, I can just run curl and say, here is the body, but I don't need to specify that this is actually JSON. This will just accept something. Any guesses what went wrong afterwards? What people started doing? Or what people tried to do? So there is this problem that plain text is treated as safe, and since we by your browser, and since we never checked for the content type, you could just send JSON as plain text. Elasticsearch would interpret that and would just run your command, which again wasn't very smart, because you could just do something like this. So, for example, with jQuery, if you call this and you just post a plain text string to that, it would just create the document for you, which is not great. We changed that, but now everybody has to add content type JSON to every single request they run. And people complain a lot about that because you had to type so much more. And this is again one of these trade-offs where you can see it's coming back to you again and again. Like, you want to start simple and then you figure out these are all the loopholes you will run into over time. So you need to fix them. Does anybody remember default credentials in Elasticsearch? Was anybody using them in some pen testing maybe? Because for a long time it was called Elastic Change Me. Guess what? Nobody changed Change Me. Unsurprisingly, it was a pretty safe bet that those would be there. We got rid of them. The problem is then only, how do you bootstrap credentials? Especially if it's a distributed system, and especially if you have stuff like Docker. Because then people would say, okay, during the installation process, you just enter the password. But with Docker, there is no installation process anymore. It's just an immutable container that you should start up. Where do you put your passwords? So the way we approach it now is, if you run it through Docker, we will require you to have an environment variable, and through that you can pass in the initial password. And then with that bootstrap password, you can replace that with proper credentials later on. But that bootstrapping thing and that start is actually pretty tricky, because a lot of people assume, well, during the installation process you do something. But with Docker, or especially Kubernetes, then you don't have this initial installation process anymore. So that's making it trickier as well. We also stored credentials. You could just add them in the clear text in the Elasticsearch YAML configuration file. Yes, you needed to be root to read that, but it was still not great. So now we have key stores, but right now, they're only called obfuscated, and we will add proper password protection later on to those. So this is still a bit work in progress, without making it too hard for the users either. Who likes generating TLS certificates? Yeah. It's not a trick question. You don't have to show me. Yeah. And you're probably the crowd that knows stuff like this much better than the average person trying to set this up. So we tried to, by now, wrap this in our own certificate utility that will run the right commands in the background depending on your operating system, and you just have to pass in some variables, and it will try to generate it the right way for you. But it's still a major pain point, and most people don't want to set up TLS because nobody wants to deal with that. And I don't think we will be getting rid of that. Anybody knows how authentication is working in Elasticsearch by default? So it was one of the features how we made a lot of money, which kind of like made it complicated, because it was one of the things where we said, like, well, if you want to run it yourself, and it's easy to run behind a reverse proxy, and you probably shouldn't expose it to anything outside of your own network. So that is normally kind of a good enough protection, especially since it's just plain HTTP. So you have reverse proxies, and everybody knows how to work with those. So you can just terminate on the reverse proxy, you have basic auth, you have TLS there, and you're pretty much good. The problem is, as soon as you try to do stuff in Kubernetes, these concepts break. There is no easy reverse proxy thing, and you need TLS in your cluster. So with Kubernetes, that changed. That's why we made security free. Also because before it was driving a good amount of our revenue and enabled us to bootstrap the other processes. But by now we have kind of like other areas where we can make money as well. So this is allowing us to do stuff like that. The problem then is, should it be on by default? And we only made that change because we only made a Kubernetes operator when we released 7.1. Changing that will be a breaking change, because if you change it in the default version, then it will be different. So we might only change it in the in the next major version, if you were paying, or if you were a paying customer using the production setup, like the bootstrap checks for production, then we would require security as well. Do we need TLS for security? Yeah, we enforce that. Without TLS, you cannot enable security. And that is another thing. We might enable security by default, but we will still require TLS. And that's kind of the thing. Like, people are probably okay with credentials, but setting up the certificates is a major pain point. And we're still not sure really how to do that. I've seen that others are shipping default certificates with their stuff, but that's also a crap idea. Like, you're not winning anything. But we probably need to do something, because has anybody ever looked on Shodan for port 9200 OK response code? Like, that is the default Elasticsearch instance. And ransomware is still a thing. And you could, for example, get one of these clusters. Then you do a cat indices. Is basically, you show me all the tables. And then you see something that is called please read. And then you know, well, we're nice, so we read what people suggest that we read. And then if you read that, that might be a bit small, but you can see here, your database is backed up. Send us 0.5 Bitcoin to this address to actually get your data back. And then there's always the hope that they actually made that backup and you get your data back. Because sometimes they just say they did, because, well, you need to download the stuff, you need to store it somewhere, and they just deleted it instead. So there's always the hope that somebody really did that and you could get your data back. The problem that happened then was that Bitcoin was pretty volatile, and I think this is, depending on where you were in the cycle, like, Bitcoin was crazily expensive and changing from a day-to-day basis. So then they said, like, send us the equivalent of, I don't know, $3,000 in whatever that is in Bitcoin today. Because it was kind of like going very quickly. And then the other problem was that if you had an insecure instance, you could run into the Matroyshka problem. Like, somebody would take your data and leave the message. Then somebody else would take that message and leave his own message. And then somebody else could come and leave their own message. And then you would need to pay all of them to get back to the original person with your data, with the real data, maybe. So you don't really want to get into that situation. And it even hit us ourselves. So, for example, we were running some test instances, and here you can see the German cert sent us an email and said, like, well, you have an open Elasticsearch instance running there. Because they started actively scanning German hosters if you have open Elasticsearch instances, because so many people were ransomed. And, well, we got those ourselves. Those were test instances, so not a big deal, but yeah, something you should probably not do. So starting off with, if you have a product and you want to get a wide user base, you probably need to make it easy to use and to have, like, a growing user base quickly. The problem is, as soon as you break into, like, more serious workloads and production, you probably want to have something that is secure and not just quick and easy to use. But it's kind of a fine point, because A, it's a painful migration, and also when do you kind of do each step, and how far do you lean into the insecure region to make it easy initially? That's kind of the idea here. So I think that's the discussion part. And we have spent exactly the 20 minutes on talk, and now I'm expecting 20 minutes of questions or discussion, or I don't know. And I hope everybody is awake now. And I guess I'm passing on the microphone, that the question is also recorded. Oh, you have another one.
I have another one. So
you can
thank you, Philipp.
Pass that on. So, has anybody had any security issues with Elasticsearch? Just out of curiosity. Or with any other NoSQL data stores. I take those as well.
Yes, I had a question regarding the privileges for indexes.
Okay.
Because there are quite a few privileges that seems to be kind of duplicate. For when you index a document, you can create, write, index, update. Mm-hmm. And all of those basically allow you to do an update. And I wanted to know if there was a specific reason why you don't have a privilege that would allow you to index a document, but not update it afterwards. Because the issue is that when you want to use beats because they are lightweight and you don't want to go through Logstash, then the issue is that if you have a compromised host, even if you use client certificate or whatever, if you have that compromised host, you have the issue that because the IDs are typically not that hard to guess, then one single host can basically rewrite your whole index or try to. Yeah.
You're in luck. We're just working on that.
Okay.
I cannot promise you the exact minor version, but I think it's coming out pretty soon. I'm not if it's sure. So the next one will be 7.5. I'm not sure if it will be that or 7.6 or something like that. But it required a bit of refactoring internally.
Okay.
But this is on the way. Because this was a known pain point basically, and there was no easy way to actually do that.
Okay.
I think the one thing that you could have done is that you disable reads, because then you would need to basically know the ID to actually replace the document.
That's true, but I don't think that the IDs are so random. So
okay,
you could try to guess and
basically try to brute force the IDs out. Yeah, okay, yeah. I mean, it's not a proper security, but it's kind of like making it harder to replace specific documents, at least, that you say you cannot read the data back, and then without the ID you cannot replace it. But a proper fix is on the way. I don't want to promise a specific version, also stuff can always slip, but I know that the security team is working on that one right now.
Okay.
Because it has come up in the past.
Thank you.
I think you had a question.
Yeah.
Thank you. Thank you for the nice presentation. I'm a big fan of Elastic. I think I deploy an instance every week or so for different reasons. You mentioned if anyone had security issues, and basically before the recent changes that made security free, I think every user had security issues with Elastic because you had to go out of your way to set up even the most basic types of security for your instance. And because of that, of course, you have the showdown and all the open instances and incidents. So my question is, and I hope this is not too political, don't you think it's Elastic fault in a way that they actually locked the most basic security function after behind the main tier and then left the product itself free to use so people can get actually the functionality, which is always the most important, for example, for the business units, but the security teams are locked out, or, for example, don't have enough time to actually run after all the instances that set up all the reverse proxies and settings?
So I don't want to blame the users because security is a hard problem. But for example, MongoDB had security for free for, I think, 4+ years. Yeah. And they're being hacked left and right as well. So I think that's kind of like the nice counterexample that MongoDB had security. I think at least 4 years security has been available for free in MongoDB. And still they get ransomed pretty much as us. At least that's my counter argument here.
I mean, you can say that, but that's more of an escape, I would say, from an answer, because you can always speak because, no product is secure enough but you mentioned that you are releasing the security for free because you want to improve the security of the customers and the users. So why not do it from the beginning? Why wait until you are in version 7.1 to do a move like this?
Well, if you run a regular cluster, the first thing is don't bind to any internet reachable instances or interfaces. I think 90% or more of the breaches that we have seen would have been protected if you didn't bind to any internet accessible interface. So that would be the first step. I know there were a couple, some people told me, well, we had a firewall running and then the firewall was misconfigured for an hour and then somebody got our data in the meantime. That's a bit unfortunate, yes. The other thing was, to be very honest, security was one of the main drivers for the commercial products. And it basically allowed us to build a lot of the functionality that we have today. And basically, with the investment from the money that came from security, we can now build on top of many other things. But we probably would never have gotten to, for example, the machine learning stuff and also more of the security stuff that we have recently acquired if we hadn't had that initial fuel of keeping us going for a couple of years initially, which is a hard trade-off. But especially if you are an open source company, you somewhere need to make the money to actually keep the engine running.
Can I ask one more question? I have been wanting to meet someone from Elastic to ask this actually face to face. You don't need to answer because I know it's more of a business question. As you said, the security feature were released for free recently. Don't you think that more of a response to Amazon AWS actually going out of their way and saying, we are just going to code this and put it out for free, so everyone who is interested in using the open source version of Elastic now have also security by default for free? Don't you think it's more of like catching up and trying to make sure that Amazon don't really take the customers away from Elastic in a sense? You don't need to answer, as I said.
No, so the thing is, to be honest, we evaluated it with every major version, if security should be free or not. The decision was generally made that it's not yet the point, but then with Kubernetes, we kind of like had to make the cut. That's also why we had this weird switch that it just changed in the first minor version of 7. And this release was never planned, actually. Like, what is 7.3 should have been, 7.2 should have been 7.1. But since we have this Kubernetes operator that we were bringing out then, and you couldn't run in Kubernetes in a secure fashion, that's why we basically had to push that out. So this was really a Kubernetes decision. Like, otherwise it probably wouldn't have happened at this time.
Thank you.
Thanks for the talk. So mine is more of like potentially like more of a query. It's like, why is it so hard for you guys to bootstrap TLS? Because, I mean, it's been done before many times. There's plenty of solutions. I mean, devices bootstrap TLS all the time. Yes, it's not, it's self-signed, but you can still create certificates based on one per instance. And if you're in a public domain, you could potentially hook in things like, let's encrypt. So I'm just curious as why is it so difficult to bootstrap that TLS part?
I think one of the, generally, we don't want to have self-signed certificates if we can avoid it. And then it's sometimes, when you bootstrap the cluster, it will be very hard to figure out where will people try to connect to the cluster. So you will have a hard time figuring out the right certificate in the bootstrap process. Where we do have bootstrapping of the certificates, for example, is with our Kubernetes operator now. They do create self-signed certificates automatically, because that is kind of like a bit more of a automated environment and like abstracted away. And then we don't have to care for all the different operating systems that we support and all the different installation methods, because that starts with Homebrew and goes to tar GZ and deb and RPM and MSI, and it's just a lot of different operating systems and platforms. I'm not an expert on TLS, to be honest. I just know from my colleagues that they always say it's kind of a hard problem, and we're trying to make this better and maybe more automated. But so far it probably also failed because of resourcing, because it's probably also a lot of testing stuff and what breaks and helping out people who break TLS in a weird way, because for security, I think half of the questions we already get are probably TLS related. Even with the wrapper that we have in cert util, this one, which wraps the security credentials query.
Any other question? We are a little bit in advance.
Yes.
I guess, on the schedule.
Thank you. In terms of resourcing, I'm just curious to know how many people or how is it split in the team, like people concerned with security. What, in your experience, do you need in terms of resourcing to follow the feature development lifecycle that you're pushing out, so all the new stuff, and how many people do you need for security?
You mean as an end user of Elasticsearch? Or as Elastic? So, I mean, security is getting a bit wider now because we have so many different areas of security. So we have core Elasticsearch security people are 4 or 5 full-time people or something like that. Bless you. But then, of course, the SIEM and Endgame and all these are totally different teams, and these are way more, or internal InfoSec. All of them are different ones. But we have a couple of people full-time on security and also globally distributed. which is a bit of a feature. So ideally we have somebody in different regions and time zones that whenever some bad security stuff would happen, they could take over or they could hand over to the next person. So we have Tim in Australia, we have Johannes and one guy in Romania. We have at least 1 or 2 guys in the US. We're getting too large. I don't remember all the names anymore, but we have a couple of folks all around working on that. And it's true, for a long time it was only one person. Yeah. And that was a bit of a bottleneck. And he basically had to decide, am I fixing bugs or am I developing features? And it was a complicated trade-off. Luckily, we are in a better position now.
Other questions?
Also, if you want to have stickers, I even brought the big ones. Like, you probably know that one, the Belk or the Elk bee. Like, it's bee and an elk. And that's kind of like where the stack came from. So if you want to have stickers, grab stickers afterwards. Final chance for questions. Did anybody get hacked using a NoSQL data store? Okay, nobody dares. You can tell me in private afterwards. I'm always curious. Anything else? Normally I try to take a picture with you so I can prove to my colleagues that I've been working today. Because, we're a fully distributed company. And, okay, today I have Aaron here. But normally I'm pretty much alone and nobody knows where I am. So, let's do this one. I'm wondering if I can all get you in one picture. Wave. Very good. So this was your last chance. Any questions? No? Okay. Thanks a lot. I think we have a coffee break.
Yeah. Thank you, Philipp.